And yes, we proceed with the today session for data 650, which the main topic is the dashDB and walkthrough to the assignment for dashDB. But before that, I will be answering some questions which are coming my way. And one of them is the discussion for week 3 and 4. Actually, week 3 already gone, and we are in week 4. So this is the discussion for week 3 and 4. Do you see my screen?
Yep.
Okay. So when you go to the Watson Analytic catalog, there are many different. The only thing we are exploring these 2 weeks is Watson cognitive computing, and from all the application there, I have selected 4 of them, and you have to explore 2 of these 4. I mean, and give us your experience, your thoughts. What is the purpose? The purpose is that you can get some, let's say, some clue about what is this about. Watson is actually very complicated computer. I have a few slides just to point to the most important. And right now I'm sharing the Bluemix screen and just the services related with Watson. So from here, you have to choose 2 from the following 4: natural language processing, personality insight, tone analyzer, and visual recognition. Why I selected them? Well, these are the most, let's say, significant to get some clue what is this about. Did I answer your question?
Yes, yes, you did.
Okay. So again, I'm going to proceed with the today meeting. I have planned some overview for what we've been doing in the last 2 weeks, because I feel we have to get in line, synchronize, and then we will proceed with the walkthrough to dashDB. My observation by now is everyone submitted first assignment, the grading is coming on, but I don't know why is this different, but okay. Yes, the grading is coming on. And for what I see in the class, most of the team are working and discussing regarding the group project. The proposal is due at the end of this week, but only 2 persons from the whole class have posted something in the discussion. So my hope is you are going to get to this discussion at least tomorrow, today late, and you will surprise me with in-depth posting like in the first discussion, which was week 1 and 2. So just very quick overview. If you missed the point about Watson Analytic, I want to point why we are talking about natural language processing and Watson Analytic in this class. From the first 2 weeks, you remember that we concluded that the big amount of the big share of big data is actually unstructured data, 80%, and the value of big data is mostly in this unstructured data. So the most important characteristic of the data is the value. It's not the size, it's not any other characteristic. So that's why we are focusing so highly in what is natural language processing, which has to do with one of the big component of big data, which is text. Text is actually, in any businesses today, they try to analyze unstructured text. So this graphic here very clearly represents what are the challenges of our natural language processing. We can have the information in very structured way. Here to the left, which is the structured column and a row, in which in each column you have the same type of data, and in the row you have different entities. Very easy to match the name of the person with the organization in which it works. But if we get the information here from this table and put it in unstructured way, like in the phrase here to the right, you will see that in order to interpret what is in this phrase, we need to think in the context, because maybe instead to think about the tenure of Jack Welch in GE, we can think about a painter. So, and this is just the way to see our language as a human. Sometimes we want the machine can interpret to interpret our natural language, but even we as a person, sometimes we don't understand each other depending what is the expression. For instance, if we read the second bullet here, ship by truck and send cargo by ship, not always for the first time we are going to understand this expression. And this is just to point to the challenges to interpret natural language processing. And moreover, when it is in this unstructured way, which is most of the information today businesses have. Starting with healthcare, the medical record is exactly this unstructured way, how to interpret this. So we've been talking about, there are many resources posted from since the previous week about the main item in natural language processing, which are the lexical, syntactic, and semantic analysis, and the most important thing, the inference. Why the inference is very important? Because this is already part of the cognition which we as a human rely on in communicating with natural language. Very simple inference, let's say, it's not raining anymore, but you can infer immediately that it was raining before. Just very simple. So from simple to most complicated, with all these challenges, we as a human rely in the context. And more often, not only in the context of what we are talking about, of the actual context, but maybe we rely in some historical data, which extend beyond of the document we are analyzing, this unstructured text, and even beyond of the actual knowledge. We go beyond the border of, so context extends to all the knowledge, even historical, which adds more complexity to the natural language processing. So all these things I'm talking today is to go to the paradigm shift, which is cognitive computing, and why is it important in big data analytics? Well, the paradigm shift, just historically, until the 40s, we were in the tabular machine. Then the programming era, which is almost at its end, is the today era of computing, which is the computer I'm using right now to hold this meeting. But let's say around 4 or 5 years ago, practically, theoretically this started much earlier, practically we are in the era, started the era of the cognitive computing. What is the difference? When we talk about cognitive computing, we don't think about something which is programmed explicitly from before, like the computer we are using, in our everyday life today. We are talking about learning and learning by experience, different type of sensor reading and reasoning, the same way like we learn as a human. That is part of the cognitive computing. And moreover, we cannot expect that the answer is going to be, let's say, the traditional computer is making calculation, calculating differential equation, exponent, giving you numerical answer. From the cognitive computing, you don't expect to get a numerical answer. You expect with some probability to get probabilistic answer. And this probabilistic answer is going to be closer to the reality, depending on how much training the computer has performed in the area. Let me give an example of what I'm talking about. So we're talking about computer which has to learn like we human learn. And to learn, we have to provide the input information. But let's say I'm training this cognitive computer with healthcare data about cancer, right? And he acquires knowledge about cancer disease, how to detect this disease, and to be a helpful tool in the hand of medical personnel in detecting this complex, this complex illness. On the other hand, I suddenly want to query the computer with questions related with cybersecurity policy. As you can expect, I cannot get reliable answer. So this is totally different from what we are accustomed from the computer, but the condition of the technology have provided us with the opportunity to get this in place. Why? Because of course we need more powerful hardware and more advanced in what is machine learning and artificial intelligence algorithm which is possible to implement in existing infrastructure. So I'm talking about cognitive computing as a paradigm shift, which the research started some decades ago, but the practical realization is possible today because of the advancement of the technology and of course of some brilliant minds which were able to put together very complex, let's say, organization of the computer, which is able to approximate to our understanding of cognitive computing. So, in short, we are thinking about a machine which will be very close to the way we learn and we understand our reality, and we can give answer and solution to different problems. And of course, we can think about cognitive computer just working with us together, not to substitute human. I just feel that this is needed in order to go to concrete example of cognitive computer, which is actually practically the first one, which is the IBM Watson. Relying in the three key areas we were talking about. Natural language processing with all the complexity to understand it, from 100,000 of writing documents or by speech, generating hypotheses given the question, and doing, let's say, a hypothesis generation by the posed question, and by evidence learning, calculating the confidence with which this hypothesis could be close answer to the question posed. This is just very in general and described very close the way we as a human do our learning and cognition in order to solve the problem of our everyday life. So something very similar to the human acquiring sensing and inferring answer. Inferring. So let's say the following. We can think, the professor is pointing that the today technology made this possible. Let me think about, then a possible solution will be we can have a supercomputer, since we have Hadoop, the technology is getting cheaper and cheaper, and in this supercomputer we can load all the textual information from Wikipedia, from hundreds of libraries, and just with very sophisticated and fast search, I can find the answer to my question. Well, practically impossible, even with the today technology, because you can imagine the size of all this information in order to find an answer to any question. Most probably, your question is not going to be the answer to your question is not going to be explicitly loaded to this computer. So that's why we rely in what is artificial intelligence, machine learning, and we train this machine even if the answer is not explicitly to infer the answer given certain information provided in the computer. So mostly this is the idea of the cognitive computer. The answer is not there explicitly. It is inferred with probability, with some confidence, some confidence interval calculated, given the different hypotheses generated. All they are weighted, and the answer is probabilistic. Of course, closer with better training in the subject. I think with this we can move forward, and the most important what I expect for this discussion in week 3 and 4 is that you surprise me with in-depth understanding at least of these 4 applications. Why? Because today businesses, if you at least review the reading posted in the classroom, you will see a tendency in all this area I have listed here, companies are moving to cognitive application. So in this class, when we talk about Watson, which is the leader in cognitive computer right now, we are talking about this type of application because actually this is a need in the businesses today. They are moving in this direction in healthcare, in government, in banking, in automotive. They try to get a handle and value of all this unstructured data, which only is possible in this intelligent way, let's say, which is the cognitive computing. And you can read, and what I'm most interested is not to understand in deep how exactly what is constructed inside. Nothing wrong with this. If you wish, you are welcome, and I will be glad to provide more information to get clue about the internal, let's say, how Watson is built internally. The most important issue here in our class in big data analytics is to get handle what are the benefits, business benefits of Watson Analytics, which could solve problems in any of the industry you are working right now or you will be working in near future. So that is the main purpose of this discussion, to find why and how Watson application can be useful in any of the businesses. So up to here, any question related with the discussion of week 3? And then we move to dashDB. Any question up to here? No. So we are moving to dashDB. Very quick, I want that you understand what is in-memory computing and why is it important. You understand that in the big data world we are living today, businesses want full advantage of the data they own. So the tendency in the last few years has been, sooner I get value of this data, I have more competitive advantage compared with the businesses in my field. And since businesses want a faster answer to huge amount of data, naturally processing in memory is much faster, and with the reduction of the cost of memory, a new advanced technology is possible today. So most of the solution in memory analytics, we are talking about all this information from sensor, from Internet of Things, from social media, or other. And the technology today made possible that the value of in-memory analytics, which was, let's say, $5,000 per gigabyte, with the new in-memory processing acceleration, new technology, which is not just the bare memory of CPU and memory. The memory is getting cheaper, but you still understand that in the traditional one number architecture, there is a bottleneck between the CPU and accessing the memory. We're talking about beyond this. Accessing memory still is a bottleneck. So we cannot get this fast processing of big data. In-memory analytics is a technology which combines accelerator, very sophisticated accelerator, which made possible to down the price of memory in-memory processing from $5,000 per gigabyte to less than 1 penny. So that's why businesses today are moving very fast to all this offer in memory analytics. Here I have some application. You can read about more applications, and if you wish to share information, we have a topic to do this. dashDB is one example, and the good thing is we have free access to this wonderful new technology, which is to provide a data analyst with in-memory analytic possibility. You can have up to 1 gigabyte free. And the wonderful thing, we're interested here from analytical point of view. The wonderful thing that we can process using this high performance in-memory technology with the BLU accelerator, which is IBM technology for in-memory analytics. We have built, dashDB has built analytic predictive modeling and business intelligence, which are our point of interest. That's why we are exploring these two from point of view from the topic of our classes. Here I have the most important listed, the most important, let's say, the most important characteristic of the technology IBM is using. Don't think this is just simple, you pour this data to the memory. No, this is very complicated technology which, for instance, data is prefetched in a buffer, so it's ready for fast processing. data which is not needed for certain processing is kept, and much more and more. That is part of the technology. There are several reading in the class which you can observe of this, and the most important characteristic is the massive parallel processing, which leverage this dynamic in memory, and most importantly, the data is organized not in the classical row table, is wide column technology, which is the typical technology for the typical NoSQL technology to organize big data. Is one of them is columnar organization. So dashDB has this massive parallel processing based on wide columnar store technology for the data, and this makes possible in memory analytics very fast. Just the last item, to scale out, let's say, if you ask additional server for, if let's say comparable, if the processing you are doing with one cluster is 1 hour, and you add just for server, your calculation will end up in 15 minutes. So it's scale up linearly, very simple. This is very wonderful technology because not all big data technologies scale out this way. You add 4 and the time is divided by 4. Not all of them. So that are the most important characteristic. What we are interested is summarizing this from analytical point of view, is summarized in this slide. We are interested in the predictive modeling algorithm built in, linear regression, association analysis, decision tree, and clustering. So you will be exploring at least one of these built-in modeling algorithm, and you will be using R to do analytic on Twitter data. So with this, we are going to match also the next week topic, which is sentimental analysis. We already are preparing everything to talk about sentimental analysis next week. This week, you will start analyzing Twitter data to get sentiments, for instance, and also some sentiments you can explore from exploring Watson application from the three from the 4 Watson application I suggested for the discussion. You can get sentiment from them. So from previous week and this week, we are preparing to the next week. This is the way everything is built one of the other. So we start part of the sentimental analysis practically analyzing Twitter data this week. The good thing is there are external connections with different tools. We are going to talk shortly about this also. And next, I'm going to give the word to Elena. She's going to do the walkthrough for dashDB. So you save time instead to go, let's say, iteratively. I hope this is going to be very helpful to get you speed up to this practical application of the tool we are exploring. Elena, are you ready?
Yes. So
Okay.
should I assume that everyone on the call is comfortable with adding the service from the catalog to the dashboard? I hope so.
Maybe not. I don't think they have started.
Okay, but in general, because they started working on week 3, right, where they had to add the service to the dashboard. Let me show.
Oh, for Watson, yes.
Yeah, so the same process is to add the dashDB service to the dashboard. So let me go.
Okay, before that, no, let me give you the ball. Before that, if any question up to here, and we are moving on. I cannot find the both. Yes.
Hi, this is Dave. I put it in chat just so that I would get my question clear. So, sorry, this is from the last time you asked for questions. I was scrambling to get to the mic. I didn't get there in time.
Okay.
That's okay. So, I was going back, if we can, to what you're saying about industry applications for Watson, and it sounded like you were saying that you would appreciate if we put into our discussion post that aspect of things about how Watson relates to specific industries. Is that what you were suggesting, or did I misunderstand what you were proposing that we do?
Yeah, that is what exactly I'm suggesting, because actually for us as a class, this is the most important. As a data analyst, what we are interested is to explore and to get handle as a data analyst what benefits I can get from this to my company, to the data I have to manage.
Sure. Yep, that makes sense.
Of course,
okay.
they are other make sense or not?
You know, it's fine. I was not gathering that from the way that the discussion was presented. The request was for the discussion post, but I will put that in. That would be good. Thanks.
No, there are many. I put many questions. All they are, but you don't have to answer to all the questions. The way the discussion is formulated, I got it, your question now. Okay, I see. Yeah, the way the discussion is worded is exhaustive of all the issues. Exhausted all the issues related. What I want to say that given the time, the most important issue is the business value where it can be applied. Not because the others are not important, but I mean, you don't have to answer all of them. Engage in what is more interested for you. If for you the interest is what is the infrastructure of Watson, how these people were able to create this, so you are welcome to discuss this. No restriction. Just I want to say what is most important from point of view of data analyst. But I worded all these questions because whatever you want to discuss in this realm is welcome. You are very welcome. Okay? Did I answer now or complicate this more?
No, that's good. That makes sense to me. Thanks.
Okay. More questions? I'm sorry, I was not looking to the chat. I was just concentrated in the shared screen, but now I'm going to look to the chat. Elena, you have to unmute yourself. We're not going to hear anything. She's not.
I almost forgot to do that. I almost forgot to do it before I started to share screen. So let me do this. I'm gonna share my screen. Okay. So basically, the way you need to start is you need to go to catalog and you need to add the service. But something else I wanted to tell you to keep in mind is that in our plan, we are limited to 10 services. You can only have 10 services on your dashboard. So that's something to keep in mind. So you would probably need to remove anything that you're not using, right? So what you need to do is you want to pick the data analytics category, and what you need to do is you have to go to dashboard right here, dashDB, I'm sorry, right here. And I'm not gonna do it now because I already added the service, but you would need to hit create. And if you do that, you're gonna add a service to your dashboard. So that's one service. You need another one, and it also comes in the same category, and it's called the Twitter application. So basically what's going to happen is your dashDB service is going to use this Twitter application. This Twitter application will be called from dashDB service, but to do that you need to add this to your dashboard, right? So you want to do that for both, right? And also, very important, that's where people make a mistake. You want to make sure that on your dashboard, you have only one copy of dashDB and only one copy of the Twitter application, right? So now, what I'm going to do, see this is Twitter, and this is dashDB. So I'm gonna click on dashDB right now. Now here, something very important. Before you log in, look at this, service credentials. Very important, pay attention. Here, this is your username, right? So what I recommend you to do is to copy it down in anything, like you can use a text pad or a notepad, copy this down, and then take this password and also save this. I'll show you why, because you're gonna need this to access RStudio. And speaking of RStudio, right now I'm using the well, basically I wanted to say that RStudio is not gonna work from Internet Explorer. Okay, so you have to use either Google Chrome or the Firefox. So Internet Explorer, the RStudio, it just won't work. It's a system requirements. Now, you write this down, right? You write down this user ID and the password. And I'm gonna show you why you need it. So you can think of it as a two-factor authentication, because you need to be logged into Bluemix, right? And then from Bluemix, you would need to be logged into R, but I'll show you, we'll get there. So now I'm gonna get back to manage. And if I scroll up, I need to say open. And now dashDB is gonna open in a separate tab. So now I have to give it a couple minutes or a minute to load. Okay, and it's gonna take you to the landing page. And the landing page has a menu. Here it is, the menu on the left hand side. So what you'll need to focus is load. You're gonna need to focus on the load part first to get the data, right? And what you want to select is a Twitter, right? Because we want to load the data from the Twitter. And this is gonna take you to the screen. Oops, I'm not sure why I'm getting pop-ups. This is something new from this application. Anyway, now I'm saying connect to Twitter. Here I want to say that I want to use my existing service that I already have added on my dashboard, right? So now what I need to do is I have to scroll down and I'm gonna hit next. And now I need to select the topic of interest. And if you notice that in your tutorial, in your walkthrough, I'm using UMUC, right? But here, let me use something different. Let's use UMCP. But what I need to do is before I put the tag, right? I have to put the hash first, and then I put my UMCP. That's a search criteria, right? And I'm gonna get the tweets count. I'm gonna do that first. So there are 91 tweets, which is not bad. And here it's giving you the estimated load times. So depending on the topics that you choose, you may need to enter additional criteria, and you could click on the search help to learn more, right? So now I'm gonna hit next. Next. Alright, and what it's telling me in here is it's going to create this 7 tables, right? It's going to create the 7 tables. Here is a table suffix. What I need to enter in here is a prefix. Since I want my tables to be descriptive, right? I just want to know or have an idea what data is stored in my table just by looking at the table name. I'm gonna put UMCP in here, right? Now what I'm gonna do is I'm gonna hit next. Oh, I have 2 options here. I have 2 options. Option 1, I can create new tables. Option 2, I can append this data to the tables that I already have. And I already created 7 tables with UMUC data. Now let's try UMCP, and I'm gonna click on next. Now, next screen here is where you need to be patient. For me, maybe I'm lucky, it's quick, right? So you need to keep in mind your connection speed and also other processes running on your Windows. If you're a Windows user, I'm sure something similar could exist for Mac, but there is a handout in the classroom that I would recommend you to check, right? Because if you have a lot of background processing running, it could slow down this application. Now, what I have to do is click next, and here, very important, because somehow this page, I have not been able to find a way to get back to this page. So very important, after your load is finished, you're going to take a screenshot of this page, right? Because I asked you to, you need to interpret this, right? So here are the related hashtags, and for some reason, this is one of the drawbacks. It's case sensitive. See this? UMCP uppercase, it's not the same as UMCP lowercase. And here it just gives me a list of suggested searches that I might be interested in, right? So see this? You've got the sentiment analysis over here, where you could analyze if a post is positive, negative, or neither. Now, so make sure to take the screenshot, all right? So now we're gonna go here is a data tab. That's basically you want to preview what data you loaded, and you can change the table name, right? So that's what it is. Okay, and here you could use filter to filter the data out. So not a big thing, right? Now another part of it is doing the queries. So let's get to this. Or first, let's look at the tables first. Tables, and I'm gonna show you what's happening. So here, this is my username. Your username is a schema. Schema is your username, something important to remember. Now here is a list of tables that I already have, right? Tables and views. Sentiment is a view, and it's explained in walkthrough how I created it. So here it is. That's a list of my tables, and in order to see the structure, I can just go and pick from here, and here it just show me the structure. Why is it a good thing to check? Because when I write my queries, I want to make sure that I get the correct spelling of my column names. So I could just do this. I could take this, copy and paste into my. I can copy and paste this into my text pad, right? I can copy and paste my column names. Well, it's just one suggestion to do this. So that way, when you type your queries, you can just copy and paste because you don't want to make typos, right? Now, you could also filter out because suppose that the table has 1,000 columns, so just an example. You can filter what you want to see. And you can also browse data from here, right? You can browse data. And one way to verify the load is you can check the number of records in here. You can check the number of records in each table that were loaded. See this total? It's right in here at the bottom, right? So now let's go to the SQL part. Run SQL. So here is, I want you guys to pay attention a little bit because there was a recent update to the interface. And as we all know, sometimes it takes some time for the documentation to be updated after the interface was updated. So here they're giving you some sample queries, and what you could do here is that this is a new functionality: run selected and run from cursor. So if I do run all, it's going to run all statements that I have over here. So those are the sample statements and therefore the sample schema. This is a sample user, okay? So if I go here, if I hit run all, it's going to run everything that I have here, all the queries in the worksheet. Now, I'm showing you this because I want you to see what information you're gonna get. Here is the log, and if you click on the log, see this? It's showing you how many statements ran. It's showing you how many statements failed. It shows you how many statements were skipped. And below, you got more details for each statement. Right? You got more details. So you may want to check the log. If you're working on a query and if you're getting the syntax errors, you may want to keep it in mind. Now, here, if I click on data, it's just going to give me the preview of the data that was returned by the query. Well, I realize that this is a sample query that was there for me, but you're going to do the same thing for the queries that you write for your tables. So now, if I hover, I see the whole statement, right? Or I can click, and it's going to open a pop-up in the whole query statement. You can also filter out the data rows by just defining the filter here, right? Or you can also specify which columns you want to see. You can just uncheck, right? Or you can reorder the columns. You can change the order. But again, it's going to change the order in this output. If I rerun the query, that's it. I'm going to get the old order. Here, this download, it means you can download data into Excel file. Yes, CSV. You can export this to CSV. And I tested it and I was able to get this to work with it. What you will do is you will write your own queries. So now let's close this out. Here is error. You hit this error to close it. And let me type one of my queries right here. So what this will do is, this is going to select basic structure here of the select statement is select. Here I'm listing the columns that I want to select, and here's my table name. And to get the column names, you would need to go to the tables tab, right? And you can copy and paste all the column names into the text pad or notepad, right? So this is a simple query. Now, what should I do if I want to run only this statement? I don't want to run the whole thing. I can just hit run selected. And it's going to run only that query. So here it is. This is a log. And I can preview, right? So what you need to do for your assignment, you need to write 5 meaningful queries, 5 queries that have a meaning. Perhaps you can do the counts of positive posts. You can do the counts of negative posts, right? But I'm just showing you example, a simple query to do this, right? So here is data. This is how you preview it. And now to filter the data, you have 2 options. The first option is to specify the filter here, right? So I could say something like this: action contains post. Now keep in mind this is case sensitive, right? And I'm gonna go here, I'm gonna set filter. That's one way. But the problem is, what if I have to rerun the query? This is going to be gone, right? So I'm better off adding the where clause in here, right? So I would have to add something like where message underscore action equals post, and post is going to be in the quotes and the lowercase, right? String comparison is a case sensitive, right? So if you need help with SQL, let me know and we'll discuss. But make sure that you understand how to write 5 basic SQL statements and explain their purpose. So that's one part. Another part is R, and you have several options in here. To do this, you go... Oh, wait, before we do that, I forgot to show you something very important. You want to make sure that you save your code that you type here. And see this? You can do export. And if you do this, you can save your script in a local file. As a local file, you can do that, right? And then you say where you want to save it and so on. You can do that, but what you can also do is you can copy this code and paste to the notepad, right? And save the file locally in a text format. Next time, if you save your file as a SQL, you can go upload next time and to open the script here. Very important, and I've been telling it every semester and still somebody does it. Never, ever, never use Microsoft Word to put your script in. Never put the script in Microsoft Word if you plan to run the script, because Microsoft Word inserts some characters that do not get recognized by SQL. And trust me, this is very difficult to fix. And the quotes is one example, right? So if you ever have to copy the code, not for grading, but in general, if you have to copy the code that you need to run later on, use a notepad or textpad, but stay away from the Microsoft Word. All right. So now we're gonna go to the Analytics R scripts. See this? Analytics R scripts. Now what you can do is you can launch RStudio. I'm gonna do that in a few. But another thing you can do is I'll show you how to generate the data frame, R data frame, from the table, right? And if you note here, you have a bunch of sample scripts that it would be helpful to look at. So let me do this. I'm gonna go here, import, and I'm going to import. Oops, sorry, I lied. I'm gonna hit on plus. I have to click on plus, and now what I have to do is I have to select my table, and see this? I just created this table, UMCP. I have to do them one at a time, unfortunately. So I hit on UMC hashtags, and I'm gonna hit apply. What will that do? This created a new script. Here it is uploading the package into memory. There is a package that is used for reading the data from the database, right? And if you're interested, there is a link to documentation in this package in the classroom. So here it establishes the connection, and here it's loading data into the data frame. Now I realize that this name is not descriptive, but you can just go and rename it. As you work on this, you can rename it to something meaningful, if you would like. So now what I can do is here, I just have one table. I want to add the rest of them, right? So you have to do this. You have to do add data frame, and then you need to select next table and hit apply. And you need to keep going, right? So basically what this does is it generates these commands. It's UMCP, let's pick locations. So basically what you need to do is you need to go through all of them, or at least the ones that you want to use, right? But in general, is it a good practice to import 5 tables? Well, think about it. If you want to analyze data stored in more than one table, you have 2 options. One option is if your SQL skills are stronger than R skills, you can create a view. And there is an example in walkthrough. You can create a view, and view joins the tables, and then the view can be added to your script the same way as I'm just adding the tables here, right? Because if I wanted to, I could add this view, but this view was built on a UMUC data. It was built on the UMUC, right? So now what I could do is I could add more UMCP users. I'm just giving you an example, right? So what you're gonna do now, let's say I want to save it. You need to save it first. So I'm gonna do this. I'm gonna hit save, and I'm gonna just type UMCP script. You want to make sure that you're using a descriptive name, right? And I'm gonna go here, and I'm gonna save this. So here is my script. Okay, so you're gonna get this message. This is not an error message. It's just telling me that I saved my file successfully. Now what I'm gonna do is, well, first of all, you can continue working from here, right? You can continue. You can just run. You can run your files by hitting submit, right? I can just do this. I can do submit, and it's going to run my script, and then the output is gonna be in here. And if my script is doing any plots, they're going to show on this top. So this is an option, right? For some reason, if you are unable to launch the RStudio, this is an option. You can use this interface to run your code, right? Now, suppose that, let's say if I'm lucky today, let's launch the RStudio. I'm going to hit RStudio. Now, do you remember earlier in the walkthrough, I told you to write down your username and password? Guess what? You're going to need it here, right? So I'll have to copy and paste. I have to copy and paste my username. and my password that I wrote down from the credentials. So I'm gonna go here, and here is the password right here. Right? Oops. There you go. Sign in. Now, very important, I wanted to point out something. Okay, here say never, never. Some browsers are trying to save the password. Never do that. That's not a good idea. If you look at it, here is my script. This is my script that I just saved. It's just going to be visible in here. And notice that I worked on something before. It's still here. And my last session, I saved this file, right? As I was checking to make, I was going through the walkthrough exercise again, and I save it right here. It's still here. Now, if I want to open this file, I just have to click like this, and it's going to open it here. That's a code that I just saved. Something very important to keep in mind is this. There is a difference in our version. We have been using 3.3.1. The version that installed in the dashDB is 3.2.1. So that's a version lower. So there could be some packages that you may have been running for this assignment in this week, right? You might not be able to use it in a dashDB assignment because of the version differences. But some good news is that you have, let me see, you have a rules package available already. You have a rules visualizations available already. You've got ggplot2. So this should all of you doing the method, right? That you want to be using. Yeah, you should be able to do the association rules easily because we have this package already installed in here. I would have to check if recursive partitioning is installed for the, oh, here it is. Yep, you should be able to do the decision trees as well because I see R part in here installed. Yeah, so you should be in a good shape here. Yeah. Installing your own packages, well, it's a little bit of challenge. It may or may not work. We'll need to play with it, but just try to use the packages that we have available. And now remember that if you're using association rule to visualize the rules, you would have to load this into memory, right? You would have to load this in the memory. Now this is in red. I know it's red, but it's not really an error. It's not really an error, just telling me that it took this version of the package and replaced it. I think this package may have loaded some dependencies. That's what I think, but well, and I realize that this is really difficult, right? To type, you can rename it as something that makes sense to you and just save it, right? So basically from here you can just do something similar to what you have been doing in RStudio, and if you need a refresher on the association rules, we have some resources in the classroom. You click on the RStudio resources by topic. So I want to see up to here, do we have any questions? Up to here. Well, I realize it is difficult to ask questions if you may not have had a chance to look at the readings, right? And earlier I mentioned that it is possible to load data from dashDB into Watson Analytics, but if you want to do that, just let me know because I have to set up something for your username on the admin side. Unfortunately, in this version of Watson Analytics, when I set up connection, the username is a required field, so I had to set up the connection for my Bluemix account. But if you're interested in this, I would need to set it up for your username. Right, so let me see if I can get into the, if I can get into the Watson Analytics. So here is Watson Analytics, and I just wanted to show you how it works. So I'm going to sign in, and what I had to do as an admin, I had to set up configure the connection. So while this is loading, if you are back to the dashDB, there is a very important screen right here. And this is this screen, connection information. See this? Connection information. And this is very important information that I had to use when I configured, as an admin, when I configured the account to be able to connect. I had to put the host name, I had to put the database name, and unfortunately this is required, right? So if you're interested to do this, let me know, and let me know your username, let me know your credentials, and I'm going to create a connection for you, right? Well, unfortunately it will be visible to your classmates, but, well, I'm going to see what we can do. But for now, let me just show you the concept. So I'm going to log in to my account. I notice that I usually use different browser for Watson and for Bluemix. Okay. So now I'm going to log in. I'm going, oops. For some reason, sometimes we need to be a little bit patient. So that's why never ever never save your password in a browser. It's a bad idea. Okay, let's do sign in, and I'm going to show you. Okay. So not sure what's going on. It's supposed to be okay. I'm gonna fix it later on. It's supposed to say your MUSI. Okay, somebody may have tried to edit the organization name. I'll look into it later. Okay, so now what I can do is I can try to add the data, and to do this I'm just gonna click on here, and I'm gonna go to connection, and what I did was I created this connection already. I created this configuration already, right? So what I need to do is I have to click on the dashDB. It's because I already created one for my account. And it's going to connect to my dashDB account. Here are the sample schemas. This is a sample data set available for me. But I'm interested to see my data. So let's see. I would have to, oh, this is me. This is my username. See this? I can click here. And do you see these tables? This is a table that I just loaded. So what I could do is I could select any of these, for instance, sentiments, and I have some options. I can upload it, or I can click shape before, and it's going to give me the preview. It's going to give me the preview here of the data. Okay. So here, this is basically showing me what data I have, and it's showing me the sentiments and so on. And if I'm interested, I can just filter this data, and I can change order. Well, you basically would need to play around with this. Right? You can reorder columns, and you can do a bunch of other stuff here before uploading the data. But the thing is, I was just trying to show you the concept. The data quality score, you get number of records and number of columns. So now, oh, that's nice. So here I'm going to click upload. And now what I have to do is I'm ready to upload to my data. Oh, wait, hold on. Let me click this and let me close this out for right now. Let me go back. So showing you again new data connection, and if you see this, you won't be able to use this because this is my account. Well, if you decide to use it, you may be able to use it, but what you will see is my account. So that's good. I don't mind if you use it and play around with data stored on my account. It's fine with me, right? So if you want to use it, you'll be accessing data from my account. That's totally fine. So now, for instance, I want to do this, and let me just do upload now. And I have to put the name. I have to put the name of this, right? and I'm just gonna save it as sentiment. Yeah, so basically that was a pop-up that I was getting earlier. I should have just went with that option. Okay, so what's gonna happen right now is Watson Analytics gonna add this tile for me, and I can proceed with this as if I was going my other Watson Analytics analysis, right? So that's one approach that you can use. And if you're interested for this to get to work for your account, I would need your credentials, and I will set it up. But you have access to access this. You have access. If you want to play with anything on my account, just for you to see how that works, you're more than welcome to. So now it's in processing. Oh, there we go. Now notice this thing here. It shows the source where the data was originally loaded, and this means the database. This means I loaded it last night from my local file. And now you may have noticed this here. You have the options to the layout. I can switch from release to the tiles, right? And I can just go on and I can do my regular analysis with that data. I can do discoveries, right? So if I click on this here, I can ask questions about this data. And if I'm not sure, I can click here, how to ask my questions, right? How to ask my questions. It's going to give me some suggestions here. And I can even pick the question type. I can do comparison, or I can do prediction, anything like that, right? Well, what I should have done is I should have used the view just to give you more. But let's try this. What drives sentiment polarity? But I should have used my view to gain more insights. But let's see what this does right now. Because what you can do is you can load tables and views, right? So for you, well, this is not going to be meaningful, but I'm just showing you the ideas. For your project, if you decide to do this, I would recommend creating a view, and then you just pull in the view in here, okay? Currently, no discoveries available. It's not meaningful because I should have loaded the view where I'm joining multiple tables. But anyway, the purpose was just to show you this functionality, that what can be done. So does it make sense, guys? Any questions? I showed a lot of stuff, and I know I may have been going too fast. But does anything I showed you make sense?
Yes, that made a lot of sense. I could follow you.
Oh, thank you. I just want to make sure that people can follow what I'm saying, and because sometimes I go too fast, I get really excited without really realizing it. Here, it's just showing me how much storage I have used. And, well, you can also load the data from the desktop in case you might be interested to explore, right? So, but do you think you guys can get started? Well, you need to do the readings before you start, and make sure you do the exercise in a walkthrough first. And also watch the videos. There are links posted to the videos. You may find them helpful. Yeah. So let's see what questions we have, because now is a good time to ask questions.
This is Scott. I have one quick question. It came from a while ago where you were showing the SQL that you could write. I guess I was just wondering, is that a robust SQL you can do sums and unions and do just about everything you would do in SQL Server or Oracle?
Yes, you can do the unions, and you can do the aggregation. Yes, okay. And you can do the joins. Because here is my code for this view. This is a view. And basically, what is a view? The view is a join, right? And you can do unions also. You can do join. And in fact, in the classroom, there is a link to the documentation that you may look at for your reference, and it shows you what you can do with queries also. And this one is the view, right? But secretly, what is a view? I have a query in there with a join. The reason I do it because sometimes I think my SQL skills are stronger than R skills, and in fact this is a recommended approach to do this. You want to create a view because inside the R you don't care in which table the data is stored. You want to have it as one single view. You don't want to be worried about merging different data frames, right? And this is basically inside I have a join in there, right? I'm joining two tables right here. Oops, I'll have to scroll down. Oops. And the nice thing here, and I like it, that the lines are numbered. It's easier for debugging, but let me show you that right here. See the select right over here. What I'm doing is I'm listing my columns. There are two tables. There is a table called UMUC tweet and UMUC sentiment. And when we join two tables, actually three, I'm joining three. When you join in the tables, you have to check which columns the tables have in common. And what I would recommend to do is create your list. Here, copy and paste the list of tables, and under each table is the columns, right? Then if you put it in Word, perhaps take a highlighter, and you may want to use different colors to highlight the common columns, right? So what I'll do is I'm going to take this table, UMUC tweet, and I'm going to take UMUC sentiment, right? On a piece of paper, kind of like highlight which columns those two tables have in common, and then join them over here on the common column. So I know that both of these tables have the column message ID. This is how I join it, right? Now I want to join my UMUC media. What do I join it to? I have to look which column UMUC media table has that any of these two tables has, right? And in this case, it matches ID. But to do that, you first need to list your tables and the columns in each table, and then you want to highlight or underline, or you can do the different lines type, like single line, double line, or anything. You can circle if you don't like to use color codes. But you have to have a way to identify which columns tables have in common, right? And also you can do the counts, you can do the regular group by heading, right? Yes, you can do unions, left joins. I'm doing left join here. So left join, basically what I want to do is I want to bring all records that I get through joining these two tables. Now I'm looking at the UMUC media, but if my UMUC media does not have a record matching this joining condition, I still want to see the row from the join of these two tables, right? So it does not matter if the UMUC media does not have a matching row, I still want to list my data. I don't want to exclude my data. That's what left join does, right? And here I'm just checking count. This is not a good idea for big tables. This is not a good idea. You won't be able to preview all data. You want to select the counts, or you want to preview the first 10 rows, something like that, right? Oh, here it is. This is an example of the aggregation. This is an example. Since some of you asked, let me see if I can type it here. So here I want to count the number of tweets by gender, right? And I want to run only this statement, so I just go run selected. It's going to run the statement where I have my cursor on. So what this did is, here we go. It's going to give me the tweet counts by gender, and no, looks like it's on something unspecified. I'll have to look in the data. So here you have male and female. So I'm giving you one example of the aggregate query, group by. And to this I can add another condition. Suppose that I want to see only if a gender has a count above 30, right? So that's going to be a having clause, having, right? So something to keep in mind, that where clause filters individual rows, having filters groups, right? But did that answer the question? Well,
yeah, just a follow-up. Can you use some of the, I know I use a lot of functions. I don't know.
yes.
You can uppercase text if it's case sensitive, things like that. Can you? Are there a lot of like string date functions that you can use as well?
Yes, and to do that, you would need to look up the. I have a link posted in the classroom, the reference where you would need to look. You need to look, the specific functions for the strings, because the syntax might be slightly different than in the Oracle, but yes, you can. Yes, you can. Let's see this. Let's see if this will work. Not quite sure if in Oracle it's proper, right? Let's see. Oh, here it's giving me an error. It's because I have to close the parentheses. Let's see this. Let's see if this does it. Run. Selected. Yep, it did it. See this? There we go. So what it did, it converted my gender to the uppercase. So yes, it means my answer. The answer is yes. See this? I was able to convert it. Yeah. So if I can do upper, I can do other functions. Sometimes the syntax might be slightly different, but the whole idea still exists. The whole idea is still there. It worked. In earlier version, it was possible to do validate the syntax, but now instead, you saw that little red pop-up that I was getting. So that's something similar. If you're not getting that in red, right, then no error. And you've got some options in here that you can do. The statement terminator is a semicolon. It's a default. I would keep the default. All right. And here it shows me if I'm running multiple statements, it shows me what to do if I get an error message. Right now I'm just saying skip it and continue to the next statement. Well, that's a default. I have not changed anything here. Right, but you have this. But some of you might be asking what's going on. Like you click on learn more. So keep in mind that the documentation, they still need to update it. It's still, because there is no validate option, right? So keep in mind that they're still working on updating the documentation, because sometimes it could take, and that's how it is in the industry too. Sometimes it takes a few weeks before the documentation is updated, but I think this new options are intuitive, but if not, let me know. Right?
Okay, this is the same way you are going to work in real world, so.
Yes. Yes.
So in the meantime, you think about question. I want to point that this is really very meaningful and exciting assignment. So just try to explore your stronger skill or develop your skill. If you are strong on SQL, go more with SQL. If you are more data scientist with R, go with R. And if you can do both, excellent. Just try to explore as much as possible, because this is very meaningful tool in the hand of data analysts.
Mm-hmm. Or like if you have time, how about if you do it both ways? You do a query in R to get the counts, and then you upload the data frame in R, and you try to get the counts in R. How about that? You get the same results? That's something to check, right? It's good to know how to do it in more than one way, I guess. Right? So if you're somebody like me with database degree, right, you're going to be good at SQL. So what you're going to do is you're going to run a SQL statement, you're going to save a copy of the results, and then when I go into my R, I want to make sure to validate my R code, I will compare the output against these numbers. So that's one way, right? You use your strong skill to develop the weaker skill. Or if it's the other way around, I can do R first and then compare with this. Oh, another thing to keep in mind, I forgot to mention it. If I load my data today and then load my data tomorrow, I'm not going to get the same result. This data is continuous in time, because they cannot stop people from going on Twitter and keep tweeting about the topic, right? You get new tweets all the time. So this is something to keep in mind. If I rerun this tomorrow, I'm going to get different results, right? I had some people asking me, why I get different results. It's because data is different. You get new people coming in and tweeting, right?
And that is the point we started talking, that in memory analytics is businesses are doing this to get real-time answer. And moreover, the data we are working, this is dynamically changing data. So you're going to get sentiment of whatever is changing. Keep all this in mind.
Mm-hmm.
So this is Vivian. I have a question. So with that in mind, should we, if we're trying to validate our results, make a copy of the data and work from that at some point in time, just to know that what we're looking at is correct? Like a test data set?
Well, I was just saying how I can work my weaker skill using my stronger skill, so to speak, right? Suppose that I'm trying to get my R script to work, right? And I know that I'm really good at SQL. I've been doing it for many years for the industry, right? So what I could do is I could just run it and save a screenshot just for myself, just as a debugging. It's part of the debugging. Sometimes we write the code to test the code. And suppose that I'm struggling, I'm trying to get the R statement to work and I'm not getting the results. I think I'm not getting the expected results. So this is your kind of like a backup plan to validate what you're getting here. So it's basically about writing code to test the code. Sometimes, well, I'm just showing you some practices. I'm not saying that that's a way to do it, but I'm just showing one way to how you can build one skill using your stronger skill.
And there is no wrong or correct way to do it. Just do it the way you feel is best for you. Sometimes you're going to be in the right track, sometime not, but that is the way it is. That is the way it's gonna happen later in your life. So actually, I don't see many very meaningful to make a copy of the Twitter data, but if you wish, you can do that.
Oh, but yeah. Another thing I was going to say, when you submit the work, make sure you include your queries, a copy of the query that you ran, and also the copy of the R script. It just shows that what you were trying to do, it kind of helps. Well, it just helps. Because sometimes, so I can look at the paper, it's very difficult to figure out how the numbers were obtained, so to speak. But if you put your script, it shows, it somewhat supports the originality that this is your work. Yeah. So it's a good practice to add a copy of the script. Do you want to add it to appendix, perhaps at least, or put it in a separate file? What way works for you? Right. Oh, for the queries, yes, I think you need to provide the screenshot of the results. For each query, you need to define the purpose. What does the query show, right? Like the one I just did, it's showing me the number of tweets per gender, because I want to know who is more likely to tweet about my topic, male or female, right? So I'm gonna do this, right? And I'll have to put the query in a paper. I would have to put the screenshot of the results, or at least partial results, if the result is too long. And I would have to explain what's the purpose of this, right? And then I would probably explain that the challenges I ran into is that a lot of tweets we don't know. The data is unknown. We don't know the gender. So this is one of the challenges here, the missing data, right? So we would have to use another criteria to analyze the information about people. We would have to look location, right? Because male, female does not tell us much, because see how much unknown I have. Yeah. So you may want to address the missing values somewhere. Well, there is no right or wrong, but try to think outside the box. Do we have more questions?
More questions?
I like questions.
Well, I think people have not started, so it's difficult to have a lot. question to preempt. And some people already left the meeting, so guys, try to think, don't try to fit in a box. Try to think openly. If you want to go above something, that is fine. If you want to go to Watson Analytics, that is perfectly fine. Beyond the minimum requirement is perfectly fine. So don't limit yourself, neither in the discussion, neither in the assignment. Don't limit yourself. That is the only suggestion I have. And if there are no more questions, all my phones, I'm sorry, are ringing. And I have, if there is no more questions, to finish the meeting and answer at least one of them. No more questions? No? Okay, have a wonderful evening and enjoy dashDB, get advantage. Bye.
Thank you.